In this presentation, I will describe how to graph a quadratic function when it's presented to you in vertex form. Let's review the vertex form of a quadratic. It's a equals parentheses x minus h squared plus k. And this gives you the information where the vertex is, which is quite useful when graphing quadratics. The vertex will be at h, k, and notice the h is an opposite side. That's important to remember. You may also notice that this can be also looked at as a transformation where we move the vertex left and right, because this value of h is inside the parentheses, and we go up and down k. Our example function is f of x equals x plus 3 squared minus 4. That tells us the vertex is at -3, -4. So let's graph that. There's -3, -4. The axis of symmetry lies on the vertex. Let's dash in the axis of symmetry. This will help us with our graphing. The next convenient point to find is the y-intercept. X equals 0 at the y-intercept. So we have the y-intercept, x equals 0. I'm going to write up higher on the graph because I'm running out of space. So let's substitute in 0 for x. And we obtain 0 plus 3 squared minus 4, and this equals 5. So our y-intercept is at 0, 5. Graph that, 0, 5. And parabolas are symmetric, which we've learned about their characteristics previously. So there's a point symmetrically opposite the y-intercept on the other side of the axis of symmetry, which would be at -6, 5. This is often referred to as the symmetric point. So we have 3 points. We like to get 5. And a convenient way to obtain another point is to look inside the parentheses and find a value that will provide us a 1 inside the parentheses. So our parentheses is x plus 3 squared. So our function looks like this. A value of x that will end up with a 1 inside this parentheses is x equals -2. Let's use the value of x at -2 and find that point. So we have 1 minus 4, which equals -3. So we have a point at -2, -3 on the graph. Let's go ahead and graph that. And because of symmetry, there's another point on the graph on the other side. This is -2, 3. This point is 2 away, so that's -4, -3. And we have now completed enough graphing of points to draw our parabola. And I'm going to go ahead and draw this. That's what our graph will look like. And I'm going to see if I can get the grapher built in here to graph. I've substituted in that equation. And if you notice, this is very similar to what we've just graphed, and you can see the overlay. That completes the presentation.